Momentum. So we're going to look at what momentum means and do a calculation on how to on momentum. So the momentum's definition is the quantity of motion. Quantity is telling me amount. So it's like how much that object is moving would be another way of saying that. So to bring a moving object to a stop, we must decrease the object's momentum to 0. If we were to calculate the momentum, we would multiply the mass of the object by the velocity of the object. So let's look at what that would look like as a formula. So the mathematical relationship for the momentum is P is equal to M times V. So P is a variable, capital P, that we use for momentum. We don't use an M because M is used for mass. Okay, so capital B, P. The units is newtons times seconds or kilograms times meters per second, because that's what a newton is a kilogram over a meter. So that's the force. Mass is mass. It's going to be in kilograms, so make sure your units in kilograms. Velocity is always in meters per second. So it's important that those units are the same. So if you were given velocity in kilometers per hour, you would have to divide by 3.6 to find meters per second. Okay, so looking at this formula, remember that we can rearrange formulas as well. So if that formula was rearranged, I want you to add to your notes as well what it would look like. So let's say I have P is equal to M times V, and I wanted to solve for velocity. I would divide off the M. So velocity is equal to P divided by M is also one of the formulas. Okay. If I start over and say, if this is my original formula and now I want to solve for M, I would divide off the velocity. So mass would equal momentum divided by velocity. So it's important that you can rearrange a formula. You'll be given this formula on a formula sheet, but I want to make sure you know how to rearrange this, because in your homework you'll get questions like that as well. All right, let's look at example 1. You can still sort of see the formulas there. What is the momentum of a 100,000 kilogram train moving at 5 meters per second? So this would be the mass. This would be the velocity. What is the momentum of a 10-gram toy moving at 5 meters per second? Which one has the greatest amount of momentum? So this is mass. This is velocity. All right, so let's take a look at this question. So I'll just say that the train is 1, or here, we'll say here, train. So in both of these questions, we're finding momentum. So P is equal to M times V. Make sure you have your calculators handy. So if P is momentum, we're just going to solve by multiplying the mass in kilograms times the velocity in meters per second. So in your calculators, take 100,000. So I'm just going to let you do that. And times that by 5. And you're going to get 500,000. A lot of you probably didn't need a calculator. And you can either put kilograms times meters per second or Newton times seconds for your units. Okay, let's look at the toy. All right, the first thing I noticed when I was looking at the mass of the toy, it's in grams. We need to convert that to kilograms. It's going to be a smaller number, so you're going to move the decimal to the left. So right now your decimal is after, so remember from going from mass to grams, to kilograms, you're going to move it 3 decimals. 1, 2, 3, so you're going to need a placeholder there. So this is going to be 0.010. You don't have to have the last 0 there, but it kind of helps you visualize it. Kilograms. Okay, so that's what we're going to use in our formula now. So our mass is 0.010 kilograms times 5. So when you do that, you're going to get 0.05. And again, you can either use kilograms times meters per second or Newton times second. Okay. So which one has the greatest amount of momentum? Train has more momentum. Now that probably was not a surprise. You're going to be able to stop a toy with your hand. You're not stopping a train from moving at all. So you're not stopping that quantity of motion. All right, one last thing to note that I want you guys to write down along with me here is you don't want to always assume, you have to consider, let me start that again. You have to consider mass and velocity, okay? And often the comparison is like something that's small, that's very fast to move would be, for example, a bullet, okay? So a bullet, and I'm just going to put in brackets, that would be very fast, but it's smaller. We'll write some symbols underneath to help us with that. Can have the same momentum as a train. So the train would be more mass. Even if it is not clearly, it's not going to be moving nearly as fast as a bullet, okay? So if I have like a little m and a big V, so small mass, high velocity, so that would be the bullet. It could still have the same momentum if we had a large mass and a lower velocity, like a train. Okay, so it's actually looking at the combination. You can't just consider only velocity or consider only mass.